Now we are going to do this practical. Okay. Now this is November 12, paper 35, number 2. Now we have this spring and we have to measure the distance here. So we cannot put the ruler here. It's not good. Better to measure it on the side here. So you can see the loop is a creating problem. So it is the first difficulty that we are getting. Okay, this is why in my uncertainty source of uncertainty I have said difficult to measure D. The loop is in the way. You can see the loop here. The loop is in the way. So there is a risk of parallax error in D. There is a risk of making parallax error in D because of the loop. So what we do, we could have used for the improvement related to this difficulty. This is the difficulty and this is the improvement. Use a vernier calipers. It's better to use a vernier caliper to grip the two here. And or a screw micrometer. Okay, so we can use a micrometer or a caliper is better to find D, the diameter of the ring. Now let us continue with our difficulty. So you put your ruler here and then you measure it. So I have taken the measurement twice. You have to make reading. For example, look here. No. Look here, you are told the value of D is the range 10 to 20 millimeter to the nearest millimeter. And for the percentage of certainty, if repeated readings have been taken, I have underlined this, then absolute certainty can be half the range. So we can repeat it. We measure it on that side. We measure it on this side. Then we measure it on this side, on the other side. Then you average the value. I have got 1.6, 1.5 average. You get 1.55. Okay, 1.55. You keep it to 2SF. I'm going to use 2SF throughout. 2SF, so it becomes 1.6. So it is 1.6 centimeter. I can write centimeter here. Okay. Now, estimate the percentage certainty in your reading D. Now, the percentage certainty. Now, in the marking scheme, you can see here that it is written for the percentage certainty. If repeated readings have been taken, then absolute certainty can be half the range. So Cambridge tell you, if you have taken two readings, you can minus this. You can add them, and no, not this here. You can take the first reading, you minus the second reading, you have the range. So now half of this will become 0.05. So 0.05 on 1.6 times 100 is 3.3. But I don't like this. I don't like this certainty because I don't like it. Okay, I like this one. Because you know what is a certainty now here? When you are measuring with your ruler, the smallest reading is 1 millimeter. So you are taking two readings, one on the top and one on the bottom. So you have an uncertainty on the top and an uncertainty in the bottom. You can make an error from the top and with the bottom, two sides. Okay, so half the smallest reading, half 1 millimeter, 1 millimeter, half 1 millimeter, half 1 millimeter. So it becomes 0.5 millimeter. So 0.5 millimeter on the top, smallest reading, okay? It is half smallest reading. This is always in science, half smallest reading. So you are taking half, you are making an error of half smallest reading on the top and half smallest reading at the bottom, on the top and on the bottom. So you have to multiply it by 2. So you have half 1 millimeter, because the smallest reading is 1 millimeter. Half 1 millimeter is 0.5. So 0.5 on the top and 0.5 on the bottom. So it becomes 1 millimeter. 1 millimeter is 0.1 centimeter. So you put 0.1 centimeter on 1.6 times 100, you will get 6.25. I'm respecting 2 SF. So 2 SF. So it becomes 6.3. So I put 6.3% here. Now you are told to put a piece of metal at this X about 1.5. So you take your ruler, you look for 1.5, then you put your 1.5 on the bottom, okay? So it is 1.5 centimeter. You put your metal here, okay? Now, what you should do, okay, you measure this. I have got 1.6 centimeter. So I put 1.6 centimeter here, also 2 SF. Okay. Now, page 7, page 8. Page 8 is here. Now I have to calculate the volume of this small cylinder. The volume is pi d square 1.6 square times 1.6. It becomes 3.2174. Now I respect to SF. So it becomes 3.2. I put 3.2 plus the unit, because if you look in the marking scheme, it is B3. Calculate V with consistent unit. Okay. So I have put the unit here. Correct. Now you arrange this, and then you put the weight, and then you put this distance, and you perform oscillation. Now I prepare this for you. Now, can you see the stand here? Can you see the stand here? And the spring is like that. Can you see that the metal strip bends on the one? It is not horizontal. Can you see it? It bends. Okay. So no problem. I can put it closer to the mouth of the clamp. Then I perform a small oscillation. Now don't forget that this distance from the bottom to the bench, it should be about 20. Okay, so I perform a small oscillation like that. Then I record 1, 2, 3, 4, 5. Okay, so I take the reading then. Okay, I don't like this because it bends when I put the mass. So this is a difficulty. Let me see how to tackle the difficulty. Now, in my list of difficulty, I have written a metal strip bends. It is not horizontal. The third one, okay? Metal strip bends, not horizontal. So what will be my improvement? So support the strip at both ends. So we can put a stand here and one more stand here. We support it, then we put the mass. Okay. No change in the reading. Okay. So this is a difficulty, and how to improve the difficulty. And also it is difficult to judge the start and end of the oscillation. Now it is difficult to check. Oh my God. 1 minute. Now for the oscillation, if it is difficult to know where to start the oscillation and where to end the oscillation. Get the point? It is too quick. So what we do, this is also a difficulty. So I have written difficulty to judge the start and end of a complete oscillation, the second one. And then for the improvement, I say use a video with timer and video and view frame by frame as told by Cambridge. In the marking scheme, you're told improve method of timing. So you use video with timer. Therefore, you film you make a video of the oscillation, and where there is a timer at the bottom, okay, and then you view it frame by frame, and the number of oscillation, and then the time taken, okay. And this is do not credit. So you should not say light gate here, okay. Should not say light gate because it is irrelevant. And this also you cannot mark the spring, things like that, okay. So you have to be careful for do not credit for what Cambridge not want you to write in your paper. You only look at these two, okay. Now, so I got three difficulty. Difficulty is difficult to measure D, as I told you in the beginning, difficulty to judge the start and end of complete oscillation, and the strip bends, not horizontal. So these are the three improvement. And for the fourth one, it is easy because 2 result is not enough to calculate K. Later I will explain this to you. Now let us continue with our reading here. So it is by page 8. So page 8, this is the value of V calculated, okay, because this is pi 3.142, D is 1.6 divided by 4, and you get this, 2SF, you get this, okay. Now you arrange this, and then page 9. Page 9, you have to make oscillation, to calculate oscillation. Now how to arrange a small table, number of oscillation 20, T1, T2, then you average the result, you add these two, divide by 2, then you take this average, you divide by 20, you will get this value. This is T capital, a time for one oscillation. Now you have to respect to SF, so it is 0.60. Now remove the mass and change the, you have to change this, the height here. You have to change it and to make it become 1.1. Okay, so it is about 1 centimeter, so you can take 1.1. So page 9, page 10 now. Page 10, when you have reduced the height, you do another oscillation. I will not do it for you, it's very easy. So here, these are the readings, how you tabulate your readings. As usual, I will use 2SF, so it becomes 0.51. Now I calculate the value of V here also with pi 1.6 is, don't forget, the distance, the diameter of the spring. So, and this is the distance below the plate, the metal plate, metal strip, and then 4. Then you get 2.2. Now I got this value. I have to respect to SF, so it becomes 2.2. I put 2.2 here. Then the number of oscillation also. I make an average. I divide by 20. I get this value. I respect to SF everywhere. Okay, so I get 0.51. Then the rest of the question very easy. You have to calculate K given a relationship. It is suggested that the relationship between T and V like that. So we put K the subject of formula. We replace the first value of T that we got. The first value of T was 0.6. And the first volume calculated was 3.2. So we got 0.15. Okay. Now for the second one, we got T2 0.51. And the second value was 2.2. The second volume. And then I got this value. I respect the 2SF. Okay. So the first value is this one and second value is this one. Now justify the number of significant figure. K is calculated with 2SF as done for the other measurement D, X, and T. You remember when we calculated D, when we calculated X, and when we calculated T. We always respect 2SF. I'll give you an example. This is X, 2SF. This is 2D, 2SF. We have D somewhere. Let me see. Yes. This is D, 2SF. Okay. So I have respected 2SF for D, X, and T. So for K also I have to respect 2SF. Now, page 11. Page 11. Now you're told that do these two values of K calculated sufficient to justify the result. So what you have to do, the percentage difference of K, we take the difference between the two values. The percentage difference of K we have to calculate. How to calculate the percentage difference of K? You take the difference between K1 and K2 and then over the average value of K1 and K2. Now the difference between K1 and K2 is 0.12 minus 0.11. Over 0.1, you add the 2, you divide by 2, the average value, you get this, times 100, you get 8.7%. Now, what you have to do, you have to justify whether it supports, whether the two results, K1 and K2, support the relationship, T square, whatever. So what you do, you take this one, you say, this is the percentage difference of K, 8.7%, is below 10%. So the result do not, the results do support the suggested relationship because it is below 10%. Say for example, it was 17%. So it would not be good because it would be above 10%. Then the result would not have supported the relationship. So it is below, so no problem, it supports. Okay, this is how you do practical. And for the difficulties and improvement, I have already explained this to you. You just have to think about the fourth one. Two results not enough to calculate K. Don't forget that we did the experiment with two values of X to get the value of K. Okay, so this is not enough, okay, to check a relationship. So what we have to do, we have to take more readings, plot a graph of T square against V. Why T square against V? Because how to get K here? We have to plot T square against V. Then the gradient will give you K. Okay, so you take more readings, you plot a graph of T square against V to calculate the value of K. This is always like that. These two readings, not enough to calculate K. This came up. This is obvious for all papers that you get in the examination. Okay, so have fun with this practical. Bye bye.